Hello, today we'll be going over the procedure of how to make and test concrete samples. This presentation will go over materials, construction, and testing procedures. First, materials dimensions. First, you will need normal weight concrete mixture, which consists of aggregate, sand, water, and Portland cement. And a concrete form, which can be any shape as long as its cross-sectional area is 9 square inches and the length should be at least 18 inches. Here are the proportions by weight of the materials you'll be using. In addition to your raw materials, you'll also need 5 to 6 5-gallon buckets to weigh things out with. Here is one example of a concrete beam layout. However, your base does not have to equal your height, as you'll see in the next slides. The materials for your form include CAD drawings of your form, which conform to the previously stated requirements. 3/4 inch melamine board for the form, 1 5/8 wall screws, and wood glue. As you can see in my CAD drawings, this beam will have a 1 to 12 taper on the sides to mimic a concrete joist, but yours doesn't have to. Be sure to practice proper safety techniques while cutting the pieces for your form in the shop, such as wearing safety goggles and a face mask. Be sure to use a combination of glue and nails while constructing your form for maximum strength. Be sure that the screws are flush with the bottom of the form to ensure an even base. In this video, we demonstrate how to zero out the scale. First, you must turn on the scale and wait for it to count down backwards from 10 to 0. After it's hit 0, you will place the bucket onto the scale and press the 0 button. Now we'll start measuring out our materials. After the bucket has been placed on the scale and zeroed out, we'll start adding our materials first fast, then as we reach our desired weight, slower. In this video, we want to go to 27 pounds. In the next few slides are pictures of the mixing process after all the materials have been measured and the forms have been built. We'll be using a concrete mixture to ensure good consistency of the concrete. You will also perform a slump test to have a visual representation of the water content of the concrete.
Ooh, it's a high slump. There you go. Okay.
After the concrete has been completely mixed, you'll be placing it in the forms. To make sure there are no air pockets, you'll be vibrating the forms to ensure that they are super smooth. Here are the forms right after being filled. After a few days after it's been in the forms, you'll pop the concrete out of the forms so it can continue to cure for the required 21 days. You will be required to find cross-sectional properties of your beam, such as Y-bar and moment of inertia. Since the practice beam is tapered, we will be testing it with the large side up and the small side up. Therefore, we will have to find S of A and S of B and MA and MB. You will have to find the anticipated load failure as well. Now let's go over proper setup for your beam in the SSA 1000 for testing. The support blocks should be placed 16 inches apart, and the beam should be placed in the loading jig and centered in between the two supports. Here's another angle of how the beam should be placed into the testing machine. Now to test the beam. Well, after placing it into the SSA 1000, you will bring it to home and run the program. After running the SSA 1000, you'll receive your test results. You'll want to compare them to your calculated load failure. If there is a large % error, it may be due to the difference in your experimental PSI and the concrete's actual PSI. Later, you'll be performing a cylinder test to see if this is the case. You will also perform a cylinder test to see what your actual PSI is. We did our calculations using 4,000 PSI, but after performing our cylinder test, we learned that we were actually at 4,228 PSI, giving us a % error of 5.4%. This difference is the reason why our calculated P and our actual P were different.